its normal level, and then it rises an equal distance above its normal level, and finally it returns to the normal level. It says the period is about 15 minutes. So you are asked to sketch the function and also come up with an equation. And I'm going to start with the 15 minutes because that I know goes on the x-axis. So making a sketch here. My graph has to end at 15 minutes. And I know it has to start at the normal level and end at the normal level based off of the information that it's kind of talking about. So the next little piece says, suppose a tsunami with an amplitude of 10 meters approaches the pier at Honolulu. So you're standing in a pier in the middle of the ocean. Not really the middle, on the edge of the ocean. So the amplitude of this tsunami is 10 meters, which can you figure that's like 39 feet? I think there's 39 inches per meter, right? Somewhere around there. So it says the normal depth is 9 meters. So the normal depth of the water is 9 meters. So using those two pieces of information, how could we try and get a little bit more sketched here, Brandon?
Since the normal depth is 9 meters, that's the sinusoidal axis.
Right, so that's where the current water level is as it's just resting. So it's resting at a location of 9 meters. That would be the sinusoidal axis. So instead of it being at 0, which like all the other problems we did were with the Ferris wheel and the water wheel, it was at 0 because it was sitting on the ground. So now the water is at a distance of 9 meters. So that would be the middle of the graph. Brandon, what else can we use with the information that's given?
Since the amplitude is 10 meters, you take 9 plus 10 to get the max, and then 9 minus 10 to get the min. Your max would be 19 meters, and the min would be negative 1 meter.
Right, so the amplitude is the distance from that middle level. How high above the middle you go, how far below the middle you go. So the stretch of the graph goes up 10 meters from the normal level of 9. So it's going to go up to 19, but it also goes down 10 meters from the normal level of 9, so it would go down to negative 1. So the negative part means that it's below sea level. And if you're at the ocean, you're at the beach, think of like the current of the ocean. So the water pulls away from the beach and you see the shoreline going down. So the normal shoreline, and then as you walk into the ocean, the further out you go, the further down the shoreline goes. The sand kind of decreases down. That's why it's negative, because it's pulling away, and I mean, as you're pulling away, like the decline, the slope of the ocean is also going down. So now we have values on the y-axis labeled. We know our normal is 9. It's going to go up to 19. Mr. Kane, I don't think asked Mr. Timko what was going on up there. And then it's going to go down to negative 1. But we know that it starts here at 9. So nothing's going on. The water is just a typical day, just a little ripple in the current. And then all of a sudden, this earthquake happens, causing a tsunami, and you're no longer standing on the pier, because if you are, you might not be alive afterwards. So you're going to run for your life, go away from the pier, get in your car, and drive like crazy. But what it's saying is from this location, it's going to go down to the minimum value. It has to come back up to normal, because the water is going away from the beach or away from the pier, and it gains all this momentum, and it comes crashing onto the pier or onto the land or whatever is there. So after it gets to the normal level, it comes back up and crashes down and ends back at normal. So it's pulling away, getting momentum, reaching its normal point, but then it goes up to the max, comes back down, and crashes. So yes, it has a circular motion, but because time is passing, we're graphing it in a horizontal format. So we need to figure out, if you're graphing this, you need to know the x value at these points. So when does it reach the lowest point? When does it reach the highest point? When is it in the middle? Libby, how could you find that information?
So first you would start with the middle and you would do 15 divided by 2. Since it starts at 0, you don't need the
Right, yeah, we don't need to add anything else extra to that. So 15 divided by 2 would be
7.5.
7.5. So, and that's just by taking the entire period, cutting it in half, because we want the point in the middle. And then, Libby, what would you do?
To find the lowest point, you would do 7.5 divided by 2. And
Because that distance is from 0 to 7.5, so 7.5 divided by 2 is
3.75.
3.75. So the lowest value, the lowest that the water goes, occurs at 3.75 seconds. And then doing the same thing for the max, Libby, that would be
You would do 7.5 plus 15 since it's in between math, and then divided by 2, and that would be 11.25.
so everything that you're doing to calculate is always cutting something in half. So you have the entire period, you cut it in half to get the middle point. And even if this was a cosine graph, we'd do the same thing, we'd cut it in half to get the middle point. And then once you have it cut in half, to find the other 2 points, you're taking that new piece, the 1/2, and you're cutting that in half. And then you're taking the other half and you're cutting that in half. So we cut things in half multiple times to come up with those 4 values that are now on the x-axis. So our graph goes down to the lowest point, is at the normal, and then it comes up and crashes back down. And then after it's all over, it settles and it's back down to normal. Or back in the middle, I guess. I don't know. Questions? So the middle of the graph is our D value. The amplitude, it already told us, was 10. And we know that the period is 15. So we have D, we have A, we need to find B. Chelsea, how would you find B if you know what the period is?
2 pi over b would equal 15, and then it would just be 2 pi over 15.
Right. So B is 2 pi over 15. And that's the information that we usually get, and then we talk about the phase shift last. So to write the equation, and it doesn't matter which you use. You could use sine, you could use cosine. But what does this picture look like? It's either a sine or a cosine graph. What does it look like? Libby?
It looks like a flip sign.
Yeah, it looks like the flip sine. So usually sine goes up the hill and down the valley. Well, this one is going down the valley and up the hill. So it's the opposite of the typical sine that we see. So it's a negative sine graph. And because the amplitude is 10, we would have a negative 10. But it looks exactly like the sine curve. The cosine graph would either start up at the top and end up at the top, or it would start down at the bottom and end at the bottom. That would be your sine or your cosine graph. So the shape of them is totally different. One looks opposite of the other. Totally different than the other, not opposite. So it's a sine graph. The B value is 2 pi over 15, and it doesn't have a phase shift because it's starting in the middle at the normal value. It's not shifting anywhere. It starts at the y-axis at 9, which is the new sinusoidal axis instead of starting at 0. And then that sinusoidal axis is that plus 9 that gets added at the end. So no phase shift necessary because it's starting on the y-axis. So if sine starts on the y-axis, then there is not a phase shift. If cosine starts on the y-axis, then there's not a phase shift. You're not shifting left or right anymore. Questions? So plugging this into the calculator, the first question wants you to see where the water is after 2 minutes. So you would use the negative 10. Make sure your calculator is in radians and not degrees. It makes a huge difference. And then we have 2 pi over 15 times 2, and then plus 9. Parentheses are a big deal with calculators because a calculator follows order of operations, and it's only going to take the sign of whatever it's connected with. And if you don't have both of these things in parentheses, then it's only taking the sign of whatever it's right next to, and that would be the 2 pi over 15. Then it's taking that answer and multiplying it by 2. But if you group these together, the calculator then knows that these two numbers need to be multiplied together first, and then it's taking the sign of that value. So this first answer should be 1.89. I believe. No, 1.57. So the first one should be 1.57 meters, and it's in meters. 1.5 meters. And then at 4 minutes, it's under sea level at negative 0.95 meters. And then at 12 minutes, it would be at 18.51 meters. Just a little less than its top, its max. So it's on its coming down part, because it takes 15 whole minutes for the whole thing to happen. So it's not like a wave that comes crashing in the ocean really quickly. It's really pooling away, and then at least you know you got 15 minutes to run. Questions? Everybody know what sea level is? Distance is measured at sea level. The city of New Orleans sits below sea level. What does that mean that it sits below sea level? Virginia? Yes, yeah. So the kind of the level of the ocean. So New Orleans sits below the level of the ocean, which when Katrina came, it destroyed the whole city because the water had nowhere to go but into the city because it was going down into it. So sea level is kind of like a normal level. So we're above sea level. Like if you go up a mountain, you're way above sea level. When they measure the height of a mountain, it's measured from sea level. Is that not geography? Yeah. Clearly, I'm really good at all of my other subjects too. So I married an English teacher because I was really good at English. But I write really good recommendation letters. Something to think about. Mine are really good. Mr. Kane helps me a little bit. All right, so the other thing I wanted to look at with you was questions 7 and 8 from the review. You're definitely going to see questions like that on the test on Friday. Friday's test is not only on graphing and writing equations of graphs, but it's also keeping you fresh with that material that we talked about in the first half of the chapter. The first problem, actually I guess technically it's 4, but these you are not supposed to use a calculator for, but these are all identities. So they're giving you the sine of 25 degrees, and it's equal to 0.4225. So finding the other values is more about knowing the location of the angle than it is anything else with a calculator. So if 25 degrees has a value of 0.4225, negative 25 degrees, just going in the other direction, would be equal to negative 0.4225. Why would it be negative? Virginia?
Because sine is the y value.
Yeah. So all functions are positive in the first quadrant. Only sine is positive in the second. Tangent is positive in the third. Cosine is positive in the fourth. So if you're finding sine in the fourth quadrant, it has to be equal to a negative value because it's your y. So that's the y value. Well, if we're in this fourth quadrant, y is negative. Number 2 says the sine of 155 degrees. Well, 155 degrees is in the second quadrant. Sine is positive in the second quadrant. So it's 0.4225. Those are reference angles. So this angle right here is 25 degrees to get us to 155. That's why the value is the same. And then for 205, well, 205 is right here in the third quadrant, and sine again is y. So that's why you have a negative 0.4225. So all 3 of those are kind of like using identities about, or properties about where sine is positive versus where it's negative. It's all the same angle, just located in a different quadrant. The last one though says the cosine is 65 degrees. Did anybody know there's an answer sheet in there? There is an answer sheet, you just have to flip a bunch of pages, it's on page 35. Does anybody know what the cosine of 65 degrees is equal to without using a calculator? Virginia?
Would it also be?
It is also 0.4225. Do you know why, Virginia?
Because it's the same as sine 90 minus the angle.
Exactly. Those two angles are complementary. So 65 degrees and 25 degrees have to be 90. When you have the sine and cosine of two angles that are complementary, they're equal to the same thing. Those were called cofunctions. That exact same question, I guess not exact same because it wasn't a 25-degree angle, but very similar question was on your first test. So cofunctions, sine and cosine of complementary angles are equal to each other. So that was no calculator because they gave you the answer. I gave you the answer. And you just had to try and manipulate that. So like, what does it mean if an angle is in this quadrant? Is sine positive or negative? All right, so if you look down at 7, because that's the one I really want to talk about. 7 says to find two values of theta. What does that mean you're finding if you're finding two values of theta? Chelsea? Yeah, so you're finding the angle. This was the last question on your first test that you had for trig. So we're finding two angles between 0 and 360. So this part tells you what your calculator needs to be in, degrees or radians, or what your answer needs to look like, degrees or radians. This is degrees. To satisfy the fact that the cosecant is equal to 2.5593. And then the first question says, which two quadrants is the cosecant positive? So, Michael, if we have cosecant, what's its buddy function?
Cosecant?
Cosecant. Cosecant,
Sine.
yeah. Cosecant and sine go together. So if you don't like thinking about cosecant, think about sine. So, Michael, where is sine positive?
Quadrant 1, quadrant 2.
Right, quadrant 1, quadrant 2. So our goal would be to find an angle in quadrant 1 and an angle in quadrant 2. When the cosecant is 2.5593. So, Michael, we can't use cosecant. We have to use sine. The sine would be equal to what if you know the cosecant?
1 over the cosecant?
Yeah, 1 over the cosecant. So you cannot use the cosecant value. Calculator doesn't have cosecant. But you can take the cosecant and translate it to a value for sine by taking 1 over that. So that would be the first step. Make it into a sine function. And then the second step would be to find the angle. Well, this isn't on the unit circle, because the numbers on the unit circle are 1/2, the square root of 3 over 2, the square root of 2 over 2, a 1 and a 0. Not on the unit circle. So you have to use a calculator. What do you use the calculator? How do you do that, Chelsea?
You take the inverse sine of it.
Right, so if you're finding the angle, because we don't know the angle, you're using the inverse sine of 1 divided by 2.5593. So this is where your calculator needs to be converted back to degrees. So the mode of the calculator is really important, going from one mode to the next. Just make sure that the question, like what is it asking for, what units are you looking for? That calculator makes sure it's just switching. So all the word problems are radians unless it specifically says degrees. But this one is telling us for this problem that we want the angle in degrees, so you have to make sure the calculator is in degrees. So when you plug that in your calculator, Chelsea, you actually get a nice answer.
23.
Yeah, you get a nice answer of 23 degrees. So this is the angle, 23 degrees. So there's my 23 degree angle, but we want that angle also in the second quadrant, which means this angle right here is also 23 degrees. So if we get it in the second quadrant, anybody know how we'd find that angle in the second quadrant? Sabrina?
You do 180 minus 23.
Yeah, because it has to be less than 180 to be in the second quadrant by the 23 degrees. That's the amount that needs to be less than 180. And Sabrina, that makes 157. So again, it has to be in the first and second quadrant because every function is positive in the first, sine is positive in the second. That's why it has to be in those two. The calculator uses the inverse function, it'll calculate the first angle for you, and then you use that angle as a reference angle to get the second one. Questions on that? Okay, so let's look at the next one, because the next one talks about radians instead of degrees. So number 8 says find two values of theta. Again, you're finding the angle. But this one wants it in radians. And specifically, it says in terms of pi. So what does that mean? That has to be in your answer. A pi. If you use your calculator, are you going to get a pi in your answer? No. So the first one you need, or number 7, you needed a calculator. This one is no calculator. So it gives us the cotangent being -1. What is cotangent, bud? So cotangent is x over y. How would you get a -1?
If you have the square root of 2 over 2 for x.
Right. So the only way you're going to get a number to be a 1 or a -1 is if x and y are exactly the same. So she said the square root of 2 over 2 for x and y. What angle goes along with having an x and y of the square root of 2 over 2? Yeah, pi over 4. So that's the family that we're looking at. Because the ordered pair is the same, that would make us have a value of +1 or -1. So x and y must be the same. All right, so in which two quadrants, this should say cotangent. So it's positive in 1 and 3, but we want it negative, so that means 2 and 4. So it's positive in 1 and 3, that has to be negative in the opposite. And again, all sine, tangent, cosine. So the angle is pi over 4, but we want pi over 4 to be in quadrant 2 because tangent is negative in quadrant 2. We want pi over 4 to be in quadrant 4 because tangent is negative in quadrant 4. So what is your pi over 4 angle in the third quadrant? Virginia? Yeah, 3 pi over 4. And if you're not sure, draw yourself a picture. Like, so 4, if you know it's the family of 4 angles, 4 pieces on the top, 4 pieces on the bottom. So to get to the second quadrant, it has to be 1, 2, 3 pieces of the pie. To go to the fourth quadrant, here's 4, 5, 6, 7. So 7 pieces would be my angle in the fourth quadrant. So if you don't have all the angles memorized, that's fine. Draw yourself a quick diagram. The denominator means 4 pieces on the top, 4 pieces on the bottom. Questions? So that first half of the packet, the 1 through 9, all of that was review material from the first packet that we had. And then at question number 10 is where the graphing starts. So there's some graphing problems on there. And there's also some rating equations. I think there's like three graphs that you're given a picture of and you're asked to rate equation in that packet, the review worksheet. For Friday, so test Friday, 50 points. The Tarzan problem, which is on page 27, that is due on Friday. If you have it tomorrow, I'll take it from you. If you have it now, I can even take it from you. It's totally up to you. But that would be due on Friday. Tomorrow, you'll have about half of the class to continue to review, work on the Tarzan problem, work on the review packet. The other half of the class, we're going to be looking at doing a little bit of intro to trying to get a tangent and a cotangent graph. And that would be like that big table of values when we started graphing last Monday. So we spent 2 weeks on graphing. When we started graphing last Monday, we filled out that chart and you plotted all those 32 points. I think it was 32 points. We plotted all the points and that's how we got the cosine graph to the sine graph. So we're going to start doing that tomorrow to get you kind of a little bit of a head start on what the sine for the cosine graph and the tangent and the cotangent graph should look like. So that'll be part of tomorrow's class. The other part of the class will be reviewing. Or working on the graph because you feel confident with your review. Question? So you have 15 minutes right now. Please use this time wisely. Ask questions. The graphs, if you notice, are still very faint because obviously the toner was running low in the copy machine. Next to Kayla is graph paper. If you want graph paper, you don't want to use the faked graphs that are on there. Feel free to grab graph paper. And I'll be around to answer